Mario and Tony both want you to come and drive go-karts for their team. You just don't throw turtle shells at each other, okay? They will pay you in gold coins. Each one makes an offer. Mario, I will give you 3 gold coins on the first day. Then every day after that, I will pay you 3 times as much as I paid you the day before. Tony, I will give you 3 gold coins on the first day. Then, every day after that, I will pay you 3 more coins than I paid you the day before. Alright, so let's say that Monday was your first D. Then, how many coins would Mario give you? Well, it says he would give you 3 coins on the first day. So 3 coins right account. And Tony as well said on the first day he would give you 3 coins. Well, the difference right here is that Mario said, I will pay you 3 times as much as I paid you the day before. So that means that on Tuesday we got 3 times as much as the day before. 3 times 3, 9. 9 coins right here. Tony, however, is going to pay you 3 more coins than the day before. So 3 plus a 3, 6 gold coins. Now, Mario says, again, I will pay you 3 times as many, so 9 times 3, bam, 27 gold coins right here. Tony, 3 more, 9. Well, then Thursday comes, and Mario says, okay, we need to triple that action. So 81 coins for you. Tony says 3 more, bam, 12. And then Mario says, all right, today's Friday. Here's your payment of
243.
243, very good. And then Tony, he's going to pay you 3 more coins, so 15 right here. So let's look at the total earnings. We're just going to add all of these. So if we add all of Mario's, 3 plus 9 plus 27 plus 81 plus 243. So there we go. Looks like Mario paid you a total of 363 gold coins. Meanwhile, Tony is going to give you 3 plus 6 plus 9 plus 12 plus 15. So it looks like Tony's giving you 45 gold coins. Alright, so who would you rather drive for? Who would you rather work for, and why? Well, hopefully by now you would work for Mario. It's a me, Mario. Alright, well, Mario. Why would you work for Mario? Because he pays you more. Mario pays a lot more. Rewrite your earnings for each day as repeated multiplication or addition. Alright, let's do that. So, for example, Monday for Mario. Let's look at Mario first. Mario on Monday is just 3. So there wasn't any repeated multiplication on these. But 9, that was the 3 from the day before times the new 3, which gave us 9. 27 was 3 times 3 times 3, because of the 9 times 3. 81 was 27, which was a 3. 3 times 3 times 3, but then we multiplied that by 3. And then 243 as well. 81, 3 times 3 times 3 times 3, but then times another 3. So there's our repeated multiplication. Now on the other hand, we got, Tony, and 3 was just the first day. 6 was 3 from the first day plus 3 from the second day. And then we're just going to have a bunch of 3's added together for these other days as well. So 12 would be Wednesday, the 9, but then another 3. And then finally the 15 was 12 from Thursday. So there's our 12. But then an additional 3. Alright, so we show this as repeated multiplication and division. Addition. Either way. Addition and multiplication, that's good. So here's the problem is, in the past you guys had seen this kind of stuff where maybe we took something like 3, right? And we added it multiple times. Something like these. And before we learned that, well, if you keep adding stuff over and over and over, then you can simplify it into a different operation, which is multiplication. Well, that gives us 3, and that's 5 groups of 3, so we did 5 times 3, and we would get 15, right? Well, that was great. This actually comes from ancient mathematicians who got tired of it just adding the same number all the time. So you can thank them for having to learn it. Okay. However, once they got past all the repeated addition, then they started seeing all this multiplication stuff happen over and over and over, like these. So they do 3 times 3 times 3 times 3 times 3 times 3 times 3, like these. And they said, look, I'm so tired of having to write repeated multiplication. So they came up with the new thing that you have to learn as well. Because, well, it's good because math people are lazy, so they kind of like to take shortcuts and stuff. And that's what this is. Okay. All right. So this is how this works, this new notation for repeated multiplication. Well, we got 3's that are being multiplied together all over the place. A lot of 3's being multiplied together. The question is, how many is there? And if we counted them, we'd find 1, 2, 3, 4, 5, 6, 7, 8. So there was 8 of them, okay? So this is where what we call exponents come into play. And we have a 3 with an exponent of 8. Now, it is important for you guys to remember the 3 right here. This is called, and they came up with a very fancy word for this value that's being multiplied by itself over and over and over. It's brand new. You've never heard it before. Base. That is the base. The base value is the number that is being multiplied by itself over and over and over. Well, what about the 8? The 8 is what we call the power. But some people prefer to call it an exponent.
See, I was right. I wasn't stupid. I was right.
Right?
I said that.
So these three words you need to be very familiar with because I'm going to use them a lot in this whole unit. We're going to be talking about the base. What is the base and what is the exponent or the power? Okay. So now if we look at Mario up in here, we should be able to write these in terms of exponents, okay? So this would have been a base of 3 that was multiplied by itself twice. 27 had a base of 3, which was multiplied by itself 3 times. 81, 3 to the power of 4, and 243, 3 to the power of 5. So now we have seen these in expanded, repeated multiplication, and also the exponential form. Alright, you have used exponents previously to represent whole numbers in expanded form as powers of 10. Powers of 10 are great because they're so easy to solve. Complete the following table to remind yourself how exponents are used. The first couple rows have been done for ye. Okay, so 10 to the power of 3 means 10 times a 10 times a 10. Now, base 10s are great because really all you have is a 1 in front. And then how many 10s did we multiply together? 3. So we should just have 3 zeros on the end of that 1 right there. Okay. Well, the next one, 10 to the power of 5, would be 10 times 10, 5 times over. So there's 5 10s multiplied together. So we got 1, and then we'll have 5 zeros, which would be the answer right here. 3, 4, 5. So that one right there is 100,000. The next one, 10 to the power of 8. So we got 10 multiplied by itself 8 times, if we're paying attention anyways. All right, so there's our 8 10s. So this again, we got a 1 with 8 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8. So then if we put on the comma so we can tell the actual value of that, looks like we got 100 millions.
Yes. Yeah.
All right, the next one, we got 10 10s being multiplied together. So let's go and write those in. There we go. So again, this is a 1 with now 10 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 10. So we can tag on some commas up in here. So this appears to be 10 billions. We don't have units for that, so that's good. 10 billions. Alright, this stuff is important for you guys to remember. We already went over it though, because right here, we got the x. What do we call the x right there? This one? It's close.
The base.
It's the base. In this case, the n, which is right here, n tells us how many times the base is being multiplied together. So that is the exponent or the power. So what we need to be able to do is to change these expressions with repeated multiplication into exponential expressions, which is what we will do. Alright, so write each expression given below in exponential form. Let us get started up and count. So this first one, what's the base on A? 6, right? Because it's a number being multiplied together. Thank you. Yeah?
Can I go to my locker and get a
What is the exponent?
7?
5, because how many 6s are being multiplied together? 5, right?
C5.
What about that hall pass? Alright, B, we got to be careful. Because on B, here's what we want to do. We want to write 9. So what is the base on this one? 9 sevenths, right? We got 9 sevenths. But here's what you're going to want to do. Is how many times was it multiplied by itself? 3. So we got a power of 3. If I see this on a test, it is incorrect. Here's why. Because right here, it looks like you've got 9 cubed, 9 to the power of 3 over 7. So what we need to do to make the whole thing to the power of 3 is just put in parentheses.
Oh.
Alright, what about D? What's the base on D?
Negative 2.
Close.
In parentheses.
It's negative 2. Yes, and notice this one gave them all in parentheses, so this one also need be in parentheses.
Why did the last one have
Okay. And then what's the exponent on the D's?
4?
4.
Why did the last
That sounds great. Let's do E then. Okay?
Oh my god.
Alright. So let's alright. So what's the base on this one? E. We're on E, right? Negative 2/3. So since it's a fraction, let's put it in parentheses. Negative 2. Yeah, and it was already in parentheses, which was extremely kind of them.
Yeah.
Well, how many of these were being multiplied together?
3.
3 of them was. There we go. Alright, so now we're on G. So this one's a fraction, so we should be using some parentheses. And what is the base?
It's X.
1x. Or 1 over x. In parentheses. And what's the exponent? 1, 2, 3, 4, 5, 6, 7. Very good. Alright, H, this one's different because we've got 2 different bases. This does not mean that we can combine the bases, alright? So in other words, the 2 bases that I have are 2 and 3, which are being multiplied together. And how many 2's did we have?
2.
How many 3's?
3.
3. That's it right there. So J, again, we've got 2 different bases. We've got x's and y's. How many x's there be? 3 of them. How many y's? 1. Now here's the thing is we don't need to write this one, but it does have 1 exponent right there, okay? So if you put it in there on a test, you'll get it correct. But if you don't put it in there on a test, you'll be correct. Very good. That's another good question. Do we need a dot between them? If you put it there on a test, this dot right here, you'll be correct. But let's say you don't, you'll be correct. Because since we have 2 variables next to each other, we just assume that that's multiplication. So whether you put it there or not is really up to you. Okay. All right. What about K? How many different bases do we have on these?
3.
3 of them. So let's identify them. What are they? A, B, C. It's easy as 1, 2, 3. That's a song, right?
Yeah.
Okay. All right. How many A's were there? 3. 3. How many B's?
3.
C's?
2.
Nailed it.
That's like my
We can do it now. Okay.
Is it?
C. What's the base on C?
15.
4. Now, this is a different notation. It's new for us.
60.
Is right here.
I don't.
These 3 dots in between right there, that's showing that it's too big for us to show in the box. So underneath it told us that it's happening 15 times. So what's the exponent?
15.
15.
Oh, excellent.
So do we need parentheses on this? No. Do we not need parentheses on this?
Yes.
Not necessarily. If you put parentheses, it's still correct. It's still 4 to the power of 15. You just got a bunch of 4s in parentheses now. That's it. All right, what about F? What's the base on the T's? X. How many? 6. What about I? 11 and X. Very good.
3 and 2.
2 X's, 3 11s. Nailed it. Do we need multiplication?
Hey, wait, I have a question.
You can if you want, but you don't really have to. So between letters and numbers like these, if you have them, that's fine. If you don't, that's fine as well. All right, the next one, L. So we got 2 bases. We got R's and Q's. How many R's does we have? 20. How many Q's? 9er. Which kind of looks like a Q, I guess. Do we need the multiplication between these two?
No.
No, but you can.
Can
You
you
can
put
if you want.
parentheses around them?
Like all of them, like this?
How many rounds? What are you?
No, all of them. Just like individually.
So like this?
Like individually, but packs sleepers, yeah.
Yeah, that'd be fine. Because this indicates multiplication between the two. Yep, so we could do it like this if we wanted to. Notice the use of parentheses in D and E above. Why do you think they are used it? So let's look at D and E. D, this one, yeah, we do have parentheses in the answer right there. That's to show that not only is it the 1 that we are taking to the power of 7, but also the denominator, which is x. And like we explained, if we didn't have the parentheses right here, then we would think it's 1 to the power of 7 divided by one single x, not 7 of them. D, we need the parentheses because that is a negative. So let's look at different examples with the negatives, okay? So with negatives, there's 3 examples that we must look at every time. Okay, so we got 3 examples. So let's look at these. We got 2 and a 2 and a 2. Now at these, this one would be -2, let's say to the power of 4. Okay, so what I want to do is expand at these. But before I do, let me ask you, how many negatives are being multiplied together right here? Yeah?
4 negatives.
4 negatives. Let's show that in the expansion. I don't know. It was just a phrase. I should. Anyways, 4 negatives. That is even. So the answer is a positive. Now this is a positive. 2 times 2 times 2
It's 16.
times 2. 16. Very good.
16 positive.
16.
Kind of a 6 class.
I just got distracted. All right, now we got to look at this example, and this is where the confusion sets in. And we need you to be confused so that we can get you out of the confusion, okay? On these, we're going to take -2 again, but raise it to the power of 4. Now, this is a trick question, so we intend for you to get it wrong. But how many negatives are on these?
No.
It's not in the parentheses. That's important to notice.
Negatives where the answer is negative.
How many negatives are there?
2.
There are exactly 1.
Ah, you got it right.
1. Okay. So this is how this expands. Is we got the negative out in the front, and then we would have the 2 times 2 times 2 times 2. Well, that shows us 1 negative.
Wait.
So this ends up being a -16 right here.
Oh, yeah.
This kind of goes back to 7th grade stuff, but we don't remember 7th grade. So I'm still going to tell you, and you guys just won't remember, okay? is the negative in the front here is telling us that I'm going to take the opposite of 2 to the power 4. So we did 2 to the power 4, which is 16. The opposite of 16 is negative 16. All right, well, what about these? Next one, right here. So let's take this 2, and we make it negative, but to the power of 4.
You have to.
How many negatives now?
None.
1. We got this one negative out in the front, this leading negative. It's just like this one above it, except for it's been written slightly differently, okay? Now we just do it very differently, okay? We're going to make this negative. Now what's
That would be a positive.
now what's the answer? How many negatives are there?
None.
How many negatives?
You're making it a positive.
Yeah.
A negative times a negative is a positive. There's 16.
All right, we got this negative in the front,
Yeah, so it's, I don't, wait.
but then how many negatives are being multiplied together?
4.
4 of them.
There's 5. I knew it.
So there's 5 negatives total. Let's look at this expanded. So this is what it would look like, 5 negatives. And if we combine these all, then we get still negative 16 though, okay? All right, so let's expand all of these. So this first one, negative 3 to the power of 3, so we just got 3 of these. So negative 3 times negative 3 times negative 3, that's 3 negatives, which is an odd number. So the answer is negative. 3 times 3 is 9, times 3 is 27. Negative 27. So the next one, let's expand negative 3 to the power of 4. So now we got 4 negatives, which is even. So the answer is positive. 3 times 3 times 3 times 3, 81.
You know, I've kind
All right, what about the next one? 5 and negative 3's multiplied together. All right, so this has an odd number of negatives, so the answer is negative. And so those 5 threes, looks like it's 243. Yeah. Now let's expand a negative 3 to the 6, so 6 of these. All right, well this one has an even number of negatives, so we got a positive answer. And multiply that by 3 again. 729er. Up and count. All right, and then we got negative 3 to the power of 7 with parentheses right count. All right, this one has an odd number of negatives, so we know the answer is negative. 729 times another negative 3. All right, so we got that filled out. Is there a pattern we noticed? And we kind of talked about this already with how many negatives there are, right? Very good. If there's an even number of negatives, like there are on these, 1, 2, 3 of these, then we get positive answers. If we have an odd number of negatives, like a here, then we get negative answers. All right, so this first one, negative 4 to the power of 2, 16. Negative 4 to the power of 2, negative 16.
Negative 16.
Next one, negative 4 to the power of 3. So that's 3 negatives, so we got a negative 64. And this other one has 1 negative, so it's still negative 64. All right, March Madness is around the corner, about 4 months. So the NCAA basketball tournament has the form of a single elimination tourney. In such a tournament, we start with a certain number of teams. There's a lot of wording in this, just so if you're not familiar with basketball, that you can learn it. Each team plays a game. This is called the first round. All the losers in the first round are eliminated. They go home. Stop playing. In the second round, all the winning teams are paired off again, and then the losers leave. This goes until we have a champion of everything. So, on these, we got 64 teams. So we're going to start with this. How many rounds are there?
5.
Well, let's look. Round 1 is going to have the 64 teams, right? Now, if we look at round 2, now remember, there's 1 winner and 1 loser every game.
So you have to divide by 2.
So we got to divide it by 2. 64 divided by 2?
32.
32. So in round 2, we got 32 people. The elite 32 is what they call it.
No, they just call it round of 32.
And then after that, 32, All 32 of those teams play, but half of them lose. Get the heck out. How many teams are left?
16.
Yeah, round 3 would then have what they call the final 16.
No, it's the sweet 16.
I was close. Okay. Well, those 16 teams play. How many teams lose? 8. 8 of those teams get out, and bam, how many teams are left? Round 4 has 8 teams. The incredible 8.
Not the elite 8.
Elite 8.
I did the whole thing on that.
Well, then those 8 teams play,
And then it goes to 4.
and then we got 4 teams play.
Fantastic.
Fantastic 4. You guys knew it,
It's the
man.
final 4.
Final. No, that's the next one. The final 2. 4. And then we got 2. We got round 6. How many teams? 2, right? Because 4 of the teams, 2 of them left. And then round 7 gives us 1 team. And then after that team plays itself, nope, can't do it. There's no such thing as that. The winner of that final game is, well, the champion. And then they go home and they make fun of other people, which isn't very nice.
They feel good about themselves.
But they get to feel good about themselves.
Who won this year?
All right. So it appears that there are 6 rounds.
Can I get out my phone?
Now, number 13, we have to be extremely careful on. How many teams were in round 2? Well, we saw. Be careful. It shows that there were 32 teams, right?
Wasn't it Arizona?
From round 2. So how many games total were played? So in round 1, there were 64 teams, but how many games?
63.
There'd be half of that, 32. Okay. And then in round 2, there'd be half of the 32 teams, 16, then 8, then 4, then 2, and then round 6 had the 1 game between the final winners, except for one goes home a loser. So how many total games were played? Let's add those together. Bam, 63 games.
Isn't it possible, like, if you're just like a really bad school,